Hello students, welcome to MAGESH classes. In this presentation, we are going to discuss about NEET 2020 Phase 2 Booster Video 6. Here the question numbers is 26 to 30 have been discussed. Let us move into the video part. Question number 26. The potential energy Y curve for hydrogen formation as a function of internuclear distance x of the hydrogen atoms is shown below. The bond energy of the hydrogen molecule. So the options are difference between the A and B and B and A and half of the C and A and half of the B and A. So we know that in x-axis the internuclear distance goes on increases. Here the energy, the potential energy in the y-axis goes on increases. So this is the point, that is the point energy A. Here the hydrogen, two hydrogen atoms are at infinite distance. So the energy is A. As the distance of between the two atoms decreases, what happens? The energy slightly decreases. At particular point, the hydrogen molecule is formed and now the energy is raised. So this area, this portion is equal to the B, the hydrogen molecule is formed. Here the two hydrogen atoms are in the distance position. So this is the place of energy of hydrogen atoms and this is the energy of the hydrogen molecules. So the bond energy is equal to the difference between A and B. That is, answer is B. Okay. Question 27. The solubility product for a salt of the type AB is 4 into 10 power minus 8. What is the molarity of its standard solution? So this is the electrolyte. Electrolyte dissociate to give A plus and B minus ion. It is a type of 1:1 electrolyte. Writing KSP, the general expression, this is the M of M, that is a cation, and it is the N of, it is an anion, and this N is the coefficient of this anion. And the molar solubility power M plus N. Here the M is the cation number and it is the coefficient. Okay, in this case, you can write 1 power 1 into 1 power 1 into S power 1 plus 1. This is KSP. So KSP is equal to S square, the molar solubility and molarity. The KSP is given, it is 4 into 10 power minus 8. This is equal to S square. So S is the square root of KSP. This is equal to square root of 4 into 10 power minus 8. 2 into 10 power minus 4 mole per liter. This is molar solubility. Your answer is B. Question number 28. At standard conditions, if the change in the enthalpy for the following reaction is, that is the formation of HBr from hydrogen and bromine. Given that the bond energy of hydrogen and bromine is 435 kilojoule mole inverse and 192 kilojoule mole inverse respectively, what is the bond energy of the HBr? So the concept is the formation of HBr is given and the bond energy of hydrogen and bond energy of the bromine and bond energy of the products are known. We can calculate the enthalpy change of the reaction. So in this problem, the enthalpy change is given. It is minus 109 kilojoule per mole. So to balance, it is 2 HBr. The bond energy of hydrogen is given. It is 435 kilojoule. And the bond energy of bromine is given, that is 192 kilojoule. What is the bond energy of the HBr. This is the question. To find out the bond energy of the any reaction is, the bond energy of the reaction is, we can write the bond energy of the reactants minus the bond energy of the product. So this is the energy of the reaction. So bond energy is nothing, it is a change in the enthalpy or free energy of the bond energy is nothing, it is change in enthalpy, it is del H. You can write. By substituting the value, it is 109. This is equal to bond energy of the reactant is hydrogen. So it is 435 plus bromine. Bromine, the energy is plus 192. So this is the reactant side, and the product side, it is the question. That is 2 into HBr, bond energy. Then true bond energy of HBr is equal to, by summing up, it will be 627 and it will be 109. So this is equal to 736 kilojoule per mole. So this is equal to bond energy of 2 moles of HBr. So 1 mole of HBr bond energy is equal to 736 kilojoule by 2. This is equal to 368 kilojoule per mole. Our answer is B. So this is the basic information you have to know. That is, the enthalpy of the reaction is equal to bond energy of the reactant minus bond energy of the product. Or the del H is equal to, in some cases, the total summation of enthalpy of formation of product minus enthalpy of formation of reactant. So this is the case, the heat of formation or enthalpy of formations are given. You have to subtract the reactant's value from product. In case of bond energy, you have to subtract product value from the reactant. So this you have to remember. The bimolecular collision reaction, the rate is given as ZAB into exponential minus EA by RT. So according to bimolecular collision theory. Here the EA is the activation energy of the reaction or gas constant T temperature, and this ZAB is the collision frequency of the reactants, that is A and B. Okay, that is the number of collision taking place during 1 second is called collision frequency. So in collision theory, the chemical reactions ZAB represent the collision frequency of the reactants A and B. So answer is C. It's a direct question. Question number 30. So it is a matching type question. In the left hand side, the coordination number and the type of hybridization is given, that is A in option A. Coordination number is 4 and hybridization is sp3, and the right hand side distribution of hybrid orbitals in space is given. So what is the correct option? So in case of sp3 hybridization, the orbitals involved are one s orbital and px, py and pz orbital. So totally 4 hybrid s orbital. It is tetrahedral in shape. Okay. So for coordination number 4 sp3, it is tetrahedral. So for 1, A is 3. So answer B, option D may not be your answer. Okay. Then DsP2. DsP2 hybridization, there is 1 d orbital is involved. Again the coordination number is 1. Here 1 s orbital and the 2 p orbital px and py, and which d orbitals are involved. So there are 5 d orbitals, dxy, dyz, dzx, dx squared y squared, and dz squared. Here the orbital involved is the dx squared y squared, that is a EG orbital. What is the structure? It is a square planar in shape. So DsP2, it is square planar. So for B, it is 4. So in this case, your answer is C. Okay. Then sp3 dehybridization. So one s orbital and 3 p orbital, px, py, pz, and one d orbital is involved. The d orbitals involved in this case is the d square. Again, it is the Eg orbital. So for 5 is a trigonal bipyramidal. And D2 sp3 or sp3 D2, it is one s orbital and 3 p orbitals, px, pz, and the D2 orbitals are 2 D2 orbitals are dz squared and dx squared y squared. So again Eg orbital. The shape of the molecule is octahedral itself. One more is there, this sp3 D3. It is pentagonal bipyramidal in shape. Here the d orbitals involved is different. It is px plus py plus pz, and the 3 d orbitals are the t2j orbital, that is txy, dyz, and plus dxz. Here the t2j orbitals are involved. So our answer is C. Okay, students, we have come to the end of this slide. I hope that it is useful for you. Thank you for watching.